guys, welcome back to engineeringtalks.com. The previous video was based on the differentiation of Laplace transforms. Today we'll learn integration of Laplace transforms and solve problems on that. So happy learning, and don't forget to like, share, subscribe the channel and press the bell icon. Today we'll go through the integration of Laplace transforms. If a function f of t satisfies the existence conditions and Laplace of f of t is equal to f of s, then Laplace of f of t by t is equal to integral s to infinity f of s ds, provided the integral exists. So, what are the conditions for the existence of Laplace transforms? First is that the function must be piecewise continuous. Second is that the function must be of exponential order. I have explained these two conditions in the previous videos. So please watch those videos first for understanding the existence conditions in detail. Now let's solve a problem. We have to find out the Laplace transform of sin alpha t by t. This is of the form Laplace of f of t by t, right? So first let's find out the Laplace transform of sin alpha t. We know that Laplace of sin at is given by a by s square plus a square. So Laplace of sin alpha t will be given by alpha by s square plus alpha square. So Laplace of sin alpha t by t is equal to integral s to infinity alpha by s square plus alpha square ds. Now we have integral a by s square plus a square is equal to tan inverse s by a. So integral alpha by s square plus alpha square will be equal to tan inverse s by alpha within the limits s to infinity. So let's apply the limits and we'll get tan inverse infinity minus tan inverse s by alpha. So tan inverse infinity is pi by 2 minus tan inverse s by alpha. Now we have tan inverse x plus cot inverse x equal to pi by 2. Therefore, cot inverse x will be equal to pi by 2 minus tan inverse x. So pi by 2 minus tan inverse s by alpha will be equal to cot inverse s by alpha. So Laplace transform of sin alpha t by t is equal to cot inverse s by alpha. Now let's find out the Laplace transform of 1 minus cos t by t. This is also of the format Laplace of f of t by t. So let's take the Laplace transform of 1 minus cos t first. So we can split and write it as Laplace of 1 minus Laplace of cos t, right? This we can split by using the linearity property. So Laplace of 1 is given by 1 by s minus Laplace of cos t is given by s square plus 1. Therefore, Laplace of 1 minus cos t by t is equal to integral s to infinity f of s ds. Here f of s is given by 1 by s minus s by s square plus 1. So integral s to infinity 1 by s minus s by s square plus 1 into ds. So integral s to infinity 1 by s ds minus integral s to infinity s by s square plus 1 ds. Now we know that integral dx by x is log x. So here we have integral 1 by s ds, that is integral ds by s. So we can write it as log s within the limits s to infinity. Here we have s by s square plus 1. Look at the denominator. We have s square plus 1. What is the derivative of s square plus 1? 2s. So the numerator must be 2s in order to apply this. That is integral dx by x equal to log x. So we should make the numerator equal to 2s. So we have to multiply and divide this function by 2. So it becomes minus 1 by 2 integral s to infinity 2s by s square plus 1 ds. Now this is of the format integral dx by x, right? Therefore we'll have log s within the limits s to infinity minus 1 by 2 log s square plus 1 within the limits s to infinity. Therefore, we can write these two terms together and apply the limits. So, we can write log s minus 1 by 2 log s square plus 1 within the limits s to infinity. Therefore, log s minus 1 by 2 log s square plus 1 within the limits s to infinity. So, we can multiply this term with 2 and make the denominator equal to 2. So, 2 log s minus log s square plus 1 by 2 within the limits s to infinity. Now, we will take this 1 by 2 outside. Now, 1 by 2 into a log b is given by log b raised to a. So, 2 log s will be given by log s raised to 2. So, log s square minus log s square plus 1 within the limits s to infinity. Therefore, 1 by 2 into log a minus log b is given by log a by b. So, we can write it as log s square by s square plus 1 within the limits s to infinity. Now, we can rewrite this term as 1 by 1 plus 1 by s square. That is, we will just divide it by s square. So, 1 by 2 log 1 by 1 plus 1 by s square within the limits s to infinity. Why we have done this rearrangement is that when we apply the limits, it becomes log infinity. Log infinity is infinity and the whole term becomes infinity. So, in order to avoid such problems in this solution, we have to rearrange this term into this. Therefore, Laplace of 1 minus cos t by t is equal to 1 by 2 into, now we will apply the limits between s and infinity. So, log 1 by 1 plus 1 by infinity square. Infinity square is infinity. So, we will write 1 plus 1 by infinity minus log 1 by 1 plus 1 by s square, which is equal to 1 by 2 into log 1 by 1 plus 0, because 1 by infinity is 0, minus log s square plus s square by 1 plus s square. Now, we can write this term as s square by 1 plus s square, which is equal to 1 by 2 into log 1 minus log s square by 1 plus s square, which is equal to 1 by 2 into log 1 is 0 minus log s square by 1 plus s square, which is equal to minus 1 by 2 log s square by 1 plus s square. Now, let's solve this. Integral 0 to infinity t e raised to minus 4t sin t dt. Now, we can rewrite this as integral 0 to infinity e raised to minus 4t t sin t dt. Now, this is of the format integral 0 to infinity e raised to minus st f of t dt, right? We all know that integral 0 to infinity e raised to minus st f of t dt is equal to f of s. Now, on comparing these two, we will get s equal to 4 and f of t is equal to t sin t. Now, let's first find out the Laplace transform of t sin t. Now, this is of the format Laplace of t raised to n f of t. Laplace of t raised to n f of t is given by minus 1 raised to n d raised to n by ds raised to n f of s. Here, n is equal to 1 because we have only t. Therefore, Laplace of t sin t is equal to minus 1 raised to n, that d raised to n by ds raised to n. N is equal to 1. So, d by ds of Laplace of sin t, which is equal to minus d by ds of 1 by s square plus 1, because Laplace of sin t is 1 by s square plus 1, which is equal to minus d by ds of s square plus 1 raised to minus 1, equal to minus of minus s square plus 1 raised to minus 2 into 2s. which is equal to 2s into s square plus 1 raised to minus 2, which is equal to 2s by s square plus 1 the whole square. Now we have s equal to 4, right? So Laplace of t sin t is given by 2s by s square plus 1 the whole square. So let's substitute 4 in the place of s. So 2 into 4 by 4 square plus 1 the whole square, which is equal to 8 by 17 square, which is equal to 8 by 289. Therefore, integral 0 to infinity e raised to minus 4t t sin t dt is equal to 8 by 289. Let's find out the Laplace transform of integral 0 to t e raised to minus 2t sin t by t dt. So first, let's take the Laplace transform of sin t by t. Now, this is of the format Laplace of f of t by t, and this is given by integral s to infinity f of s ds. So, Laplace of sin t by t will be given by integral s to infinity f of s ds. Laplace of sin t is given by 1 by s square plus 1 ds. Therefore, Laplace of sin t by t is equal to integral s to infinity 1 by s square plus 1 ds. Now, integral 1 by s square plus 1 is tan inverse s. Therefore, tan inverse s within the limits s to infinity. Now, let's apply the limits and we'll get it as tan inverse infinity minus tan inverse s. Now it becomes pi by 2 minus tan inverse s, because tan inverse infinity is pi by 2. Therefore, pi by 2 minus tan inverse s is equal to cot inverse s. We have tan inverse s plus cot inverse s is equal to pi by 2. Therefore, pi by 2 minus tan inverse s is equal to cot inverse s. Now, Laplace of e raised to minus 2t sin t by t will be equal to cot inverse s plus 2 using the first shifting property. We have already discussed this property in the previous videos. According to this property, Laplace of e raised to at f of t is given by f of s minus a, and Laplace of e raised to minus at f of t is given by f of s plus a. Here we have Laplace of e raised to minus at f of t. A is equal to 2. So, the answer will be f of s plus a. We have f of s equal to cot inverse s. So, it becomes cot inverse s plus 2. Now, we know that Laplace of e raised to minus 2t sin t by t is equal to cot inverse s plus 2 using the first shifting property. Therefore, Laplace of integral 0 to t e raised to minus 2t sin t by t dt. This is of the format Laplace of integral 0 to t f of t dt, right? We already know that Laplace of integral 0 to t f of u du is equal to 1 by s f of s. So, Laplace of integral 0 to t e raised to minus 2t sin t by t will be equal to 1 by s f of s, that is 1 by s cot inverse s plus 2. Please do like, share and subscribe the channel. Thank you.